Hello and welcome to this video on insertion sort. The problem with gnome sort, which we learned about in the last video, is that it wastes a lot of time on moving back and forth one step at a time. So when gnome sort encountered a small array element towards the end of the sorting process, it took forever to move this element to the start of the array and then come back to work on the next array element at the end of the array. Obviously, this can be improved on. What if we didn't have to swap two elements at a time over and over again to move one element back? What if we could just store this element, which needs to be moved, in memory, and then start an inner loop which traverses the array backwards, and after that, insert the element at exactly the right position? And once that is done, jump back to where this inner loop had started or where the outer loop had paused and continue on from there. This is the main idea of insertion sort. It's basically gnome sort with less time spent traveling back and forth between the array element's original positions and their final destinations. Notice that in order to insert an array element at any position in the array, we first have to move up the other elements by one position. This is done by copying them. As always, this is best explained with a numerical example. Alright, so let's have a look at how insertion sort works step by step. As always, we begin with our unsorted array 2, 4, 5, 1, and 3. And now comes the first pass. Well, first we look at this 4. 4 is greater than 2, nothing needs to be done. So we now advance in the outer loop into the second pass. This means we're now down here, we're looking at this 5. 5 is greater than 4, no change is necessary. We enter the third pass of the outer loop. Now we have 2, 4, 5, 1, and we are looking at this 1. 1 is greater than 5, but comes after it right now. So 1 is smaller than 5, but comes after it right now. So we need to make a change here. And what we do is we now copy this 5. This is the element that came before 1. And we store 1. We don't forget about this 1. We kind of store it in memory. So here's what that looks like. Now the array reads 2, 4, 5, 5, 3 because we just copied over this 5 on top of this 1. So we have now 2 5s and no 1. But we are storing this 1 in memory. We are not forgetting about it. Okay, so now we are looking at this 5. Notice that I now used a different symbol instead of this little arrow here because now we are in this inner loop. We're now starting this inner loop within the outer loop. So here we are now looking at this 5, comparing it with this 4. Same problem as what we had up here. Well, not the same problem. 5 is greater than 4, so we just keep on copying over. Okay, so we copy over this 4, and now it reads 2, 4, 4, 5, and 3. Now we are looking at this. Well, we are seeing 2 and 4. Okay, nothing to be done here because remember, we're always comparing with 1. We're not comparing 4 and 2 directly. We're looking at this 1. So we are now copying over 2, which is what we're doing here. So the array now reads 2, 2, 4, 5, 3. Now we are looking at this 2 and we're now saying, okay, finally we found the correct place to insert 1 because we are already at the very left of the array. So we are inserting 1 here. 1, 2, 4, 5, 3. Now, if this was a lot to take in, just have a look at the next pass and it should be a little clearer in this fourth pass here. So we start with 1, 2, 4, 5, and 3. Again, we look at this 3. It's larger than 5. It's greater than 5, but comes after it. So we have to make a swap here. But in an insertion sort, the way that we do this is we copy over the 5 and store this 3 in memory. Okay? So the array now reads 1, 2, 4, 5, and 5. We're now looking at this 5. We are copying over this 4 because 4 in comparison to 3 is not in the correct position. So we are copying over 4. The array now reads 1, 2, 4, 4, 5. And now, since we just copy over 4, this is where 3 now needs to go. So we take this position here, and this is where we are going to insert the 3. So the array now reads 1, 2, 3, 4, 5. Okay, so we are copying over, and then we are comparing what we copied over with this element that we need to insert, right? And we're always comparing with this element in all of the steps of the inner loop. And when we copied over an element that is just barely greater than what we need to insert, that's when we are going to insert this element. Okay, so let's start coding this. So I'm going to go down here. I'm going to define a function called insertion sort. You probably guessed this already. It's a function of A. As always, let's define n. And now we'll have the outer loop. And within this outer loop, we'll have an inner loop. Okay? So this outer loop will start for I. What am I doing here? This is the wrong syntax. This is not Python. For I in range 1 to n. So we are storing the current array element. Store current array element. So I'm just going to type, we'll call this current element is element I of array A. And now we're going to traverse backwards. So, well, this is the inner loop. Just say this. Go forward, and the inner loop go backward. Okay, so we're setting I is equal to j, and now we'll start a while loop. Say current element less than a j minus 1. So we're always, remember I is equal to j at first, or j is equal to I. So j is equal to I. This is what it's supposed to be. I mean, I is already defined up here. So j is equal to I, and now we're comparing the current element, which is the element sitting on I, with the element that comes before it. And we also got to make sure what happens when we are at the very beginning of the array. So, and j is greater or equal than 1. Okay, this is just a boundary condition here. In terms of our visualization, I think it's good to yield at this point. So we're yielding A, and then we'll yield in different colors elements I and j. Now we are making the copy, so copy over element, I think this is all we'll need here in terms of the comments. So aj is equal to aj minus 1. Copy over element from left to right. So maybe that's just to clarify. So aj, which is the element that comes to the right of aj minus 1, this is just copied over, right? So aj minus 1 is copied over to the right. And next we'll take a step left. So step left, so we'll say j minus equal 1. Now once we reach the end of this inner loop, it's time to insert the stored array element, okay? So we set the element in position j. This is where we started this inner loop, where we always step left, we step back. We could also say step back here, it doesn't really matter. It's equal to the current element, because now we found the correct position to insert this element from up here, which is what we stored, into the correct spot down here. And then we can yield once more. So let's yield the same thing, but maybe we're going to change the colors here to reach the effect that you saw in the intro section. So I'm just going to move I over here, because now we want it to be in a different color, and j will be in the same color. And if I'm not mistaken, that should be it. So I'm going to save this. I'm going to go into the animate. I'm going to say from insertion, import insertion underscore sort. And then we're going to go down here, insertion sort, capitalize this. Whoops. And this will be insertion sort. And let's not forget about this comma, which is what I did in the last video. I'm going to save this, go into the main. We'll go for insertion sort, and we're going to play this. And I think this is looking good. So we're moving the elements over, and when we find the correct spot, so when we find the correct position, this is just flickering in blue to indicate that it's done. Okay? I mean, we could also change this and make it appear blue over here when it's in the correct spot. Let's just slow this down a little. So, yeah, highlighting this in blue doesn't really make a lot of sense, because, I mean, it's just a super tall bar. You cannot really see anything. So let's make this blue when it reaches the correct position. Okay, so I'm going to exit out of this, go back into the insertion sort. And yeah, I think the problem is that I just copied this over. So let's make this I and this j. So I think this should be fixing it. So let's run this once more. And there we go. So now it's copying over, and when it reaches the correct position, I'm going to slow this down actually a little. It's yellow, 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 and then it turns blue once it found the correct position. Okay, so now we're taking this element here on this height, and then boom, that's where it happened. So focus on what happens when we take this bar here. Just a couple of steps further down, this bar here. Okay, so now you saw that we just copied over this tall bar from over here to here. Now we can really see this copying. And we were somewhere on this height, remember? And now what happens is that somewhere over here, somewhere around here, that's where the blue bar will appear. So now the yellow bar is traversing down, and then at some point down here, yeah, so at this position, this is where this bar from over here appeared over there. It's always easy to see this with the smaller bar, so let's have a look at what happens once the algorithm reaches this bar over here, which should go all the way over here in position 1, 2, 3. So I'm going to let this play until we reach this position. So we have now reached this position. We are now copying over this bar here. It's so wonderful that we can just pause this animation and reduce the speed. So we just copied this over, and now remember I said it should appear in this one, in the first, second, third position over here. So we're traversing the array backwards, going back, going back, going back, and then finally down here we inserted this. And yeah, this is really how this algorithm works. So let's just bring this back to speed. And yeah, you can immediately tell that it's a lot more powerful than gnome sort, because gnome sort always had to traverse back forward again, right? It's traversing back and then it's traversing forward one step at a time, whereas insertion sort is just going backwards because it kind of remembers where it left off because of this nested loop structure, and this just makes it a lot more powerful, a lot faster. And yes, so it shouldn't be too much longer until this algorithm terminates and the array is all sorted. Just gonna wait for this. Yeah, so let's maybe have another look at this one down here. So we just copied over, and it should travel, I don't know, I think down here. You can kind of see this step function here, and we can see that there's one step here which is too large. So this is probably where it's gonna go. I'm gonna slow this down. And yeah, we're still too fast. It happened so quickly, but it's inserted it right here. Okay, there's another super small one back here, which will be very nice to look at, going all the way back over here, because you can still see this double step that's involved here. Okay, there you just saw it, and now the array is sorted. Thank you very much for watching. See you in the next video, where I think we'll work with shell sort, which is even faster than insertion sort.